Let me conclude this prelude with a word on the teaching and the learning of mathematics. A serious student of the subject is not an idle spectator at a variety show, but learns best by active involvement. And indeed, for the vast majority of students, learning mathematics is a particularly tactile endeavour. This was codified by the British mathematician Alan Turing in a seminal paper that heralded the dawn of computer science in the year 1936. Based on his observations of how we apparently think, Turing posited a model of human cogitation and computation, where he posited that we think and compute by reading, pausing, reading again, pausing, writing, pausing, perhaps retracing our steps, reading again, pausing, writing, perhaps erasing, pausing, reading, and so on. And so, to get the most out of these lectures, a student should have a pencil in hand and paper to write on. Equations arise slowly and languorously on the screen. Pause the lecture while you write them down. Absorb the notation and the logic. Bear in mind that learning is not a linear process. You may find that you have to go back in your notes to revisit a concept to figure out, well, what exactly was that again? Think it through, and when you've understood it, come back to your current place and proceed. A student might recognize the model of instruction in a classroom. And assuredly, in a student's background, she would have had instructors who were particularly effective at delivering information which is abstract in nature. The mathematician Herb Reiser at the California Institute of Technology was well aware of these fundaments in learning. He had this pretty little trick of writing beautifully on the blackboard in perfect silence and waiting for the last pencil to stop moving before he uttered a word. His students were vastly appreciative. So accordingly, pause the lecture frequently, write down the mathematics as it arises. Feel free to go back to revisit a concept to further your understanding of something, an aha moment as it were, before you proceed. Our next lectures in this preview will introduce chance in very simple settings. And in these very simple settings for which we have a lot of intuition, we will discover unexpected and strange fluctuations, unexpected phenomena, things which perturb us. This doesn't look right. And in the emergence of such strange behavior in very simple settings, the necessity for a theory and a principled way of thinking about the subject will become manifest.